So, hello everyone. I'm happy and glad to be here with you today in this lovely evening. I know it's rainy outside, but still, it's a very vibe area of the city, so very cool to be here all the time when I'm coming back. Today's talk would be dedicated to the Gradle. It's naming a little bit obscure. I will try to highlight two main topics about how the Gradle actually gets your stuff running. And the second part would be a brief overview of the most important, from my perspective, public API that Gradle actually presents to us. And it's hard not to notice this image. It's coming from the Hindu myth called Makara. Maybe I'm pronouncing it in a bad way, but that's essentially how I perceive the Gradle when I think about this. When I'm closing the eyes, I see this creature. Actually, it looks like an elephant, but actually works like a fish, which is very weird. But that's the overall impression of the Gradle I get after the years working with it. So we will begin from something very simple, even though this is more about Android development meetup. I just picked up very simple module build Gradle file that you would write in either Groovy or build Gradle KTS. Most of the talk will focus on the build Gradle KTS scripts, but it's most everything is applicable also for the old school Groovy files. There is a third option which will come in the next release. I won't touch it in this talk, but the Gradle comes with yet another type of the scripting. So let's begin. This code, as I said, is very simple, but in reality, we receive this. We run this code in two actually steps, or more precisely says, we compile two programs to run this code. The first one goes about the plugins block. It's not mandatory to have it in the root of your file, but it's advised way how you would load some plugin in your environment. And the part that goes from 5 to 8 lines, it's just for the demo. It's pretty straightforward. The main idea behind the Gradle and its runtime is to grab the script file, which is a text file, identify its blocks, and then compile two programs, maybe more, depending on your script structure, and evaluate those. This is what meant by partial evaluation. So interpreter emits a specialized program. This is taken from the documentation. Then the specialized program tries to be smart and avoids a lot of work. But by a lot of work, essentially it means that it tries not to use reflection whenever it's not required. So for example, in case of plugins, it will know exactly where the plugins block identify and insert the line of code for the better visibility in the tools. So let's say your build Gradle file fails, you get an error, it points you directly in the line of code that has failed. And whenever we run things from either IDE or from the command line, it's all end up at these two classes that get executed by Gradle for us. It's stored outside the project in its Gradle home caches folder, and the first class is the name of your script, which is build Gradle. The second is called program. Not that much of complexity here, very generic, but that's what's actually executing your build Gradle class. So build Gradle file or class gets generated for plugins line of code as a separate instance. You can see that it inherits from the compiled Kotlin plugins block. So you get concrete type for you to work with, and the Gradle injects the plugin dependencies reference for you to configure over. So essentially, when you call the ID, you call it over this object. And if you go deeper, this is the example for the part that we saw about Java. This is another program, another build Gradle file produced for us. So let's see and explore where does this plugin dependencies comes from. So if we explore the program that gets generated for us, you will see that it has a method execute, and in reality, Gradle would execute this code for us by simply calling it from its alternative version of runnable. So when you want to post some job for your thread, you wrap it with runnable. Gradle behind the scenes does the same with the daemon. And it then reaches this code, finds it in the class path, and calls the execute for us. You will see that its execute method actually constructs for us some object called plugin request collector. It's a Java code. It's been compiled so we can see and then compiled back for us for the readability. But in reality, whenever you call ID, alias in your plugins block, it's get delegated to this object. That's why you see that the Gradle uses this word delegate, but if you speak from the perspective of Kotlin, it's a Kotlin context receiver. And there is no brainer here. Gradle simply takes this compiled class for us and creates its instance and passes the dependency spec here. And then the number 2, it says the line of code where we're actually calling this. So this is the optimization it does. So to avoid going with the reflection, reading the file again, it's compiled it, it's injected a line of codes, and whenever you get the crash, it will know exactly where the problem starts. It's handling this part for you. And it also gives you the path to this class. So let's take a look quickly in the plugin request collector. It's a Java class, so there is no explicit inner modifier. And the reason why I'm pointing out that the inner is important, because when we create a spec, we create an instance of plugin dependency specs implementation, which is an inner class. Thus, it actually contributes to the contents of the specs, which happening here, specs add spec here. So whenever you call ID, you actually add another spec to the context of the collector. The collector afterwards passed by Gradle to its runtime. It reads the coordinates of your dependency, pulls the jar, all this thing happening for you at the runtime. But the main idea is that all this happening due to us actually interacting and mutating the context of the collector through the object called plugin dependency spec. So here you can see it's better highlight. And here we can see what actually gets constructed for us. So something simple as these 3 lines of code. If you would try the code by hand, we would need to create this build Gradle file. We would request sometimes for us to get injected. So the Gradle also acts as a dependency injection runtime for you. Sometimes it also acts as a service collector, but in this case it's more like it injects for you, so you don't care where it comes from. And if you see a source code, you would find the plugins box is simply calling a context receiver read. So I've simplified it. In reality, it's an extra class, which is not that much important, but comes with additional features like resolution of the library catalogs if you use those. Remember those TOML files that now you can put in your project and get an access. This actually would be handled with more sophisticated object. And then what you would do, you create an instance of this build Gradle file and call this plugins. So this code is essentially what you would do by hand each time if the Gradle won't be there for you to help you with this. So let's take another case. What would happen? What is your opinion about that? Anyone? Would it run? Let's put it like yes or no. So I can see that people showing that it won't. And it's correct. Even though we're inside the script file, this plugins code is not the same plugins method that we get here. And it will actually crash with an error, because if you take a look into the Kotlin build script type, which actually the second program that's got compiled for us, it actually tries to be preemptive and disallow you to configure plugins once again. You shouldn't do this, and it's pretty obvious that it won't work. But this is just an example that even though you can call plugins from whenever a line of code within the script, in reality it gets delegated back to your build -Gradle file. And even then, you still need to have a plugins method definition, otherwise you will get method not found error if it won't happen. Because this code is not executed line by line, but actually copy it into one class and then copy it into another. You would get some nice explanation saying that you shouldn't do that. If you still want to do the dynamic loading, you can still do this by calling the apply. So as a summary, so whenever you work with any build Gradle files, it looks in its structure, it decides how many microprograms to generate for us. In our case, there were 2 programs, one dedicated for the loading plugins and another for executing the script body. So let's quickly take a look on what's actually happening with the build Gradle files that generated for our extension. If you try to see through the Android Studio the compiled code, you would find something called accessors. Accessor is a smart way for you to get this DSL. Java is not existing as a keyword in the Kotlin language, but it actually gets access from the object that gets generated from the Kotlin DSL library for us. And behind the scene, it simply acquires the reference to extension. And again, this is project this. It's where the build Gradle file actually delegates to our project instance. We get the implicit receiver. So we can easily typecast this build Gradle script to the project instance. And this is the main idea behind the Gradle. Whenever you interact with your script file, you're actually working with one of the existing types, such as a project, Gradle, and settings. And if you put your Gradle file inside the module, for module you will get an instance of the project. And whatever magic is happening is all happening with the help of this project type. So if you want to get an access to the extension, which is coming from the plugin, from the Kotlin plugin, and also you can apply a pure Java plugin, it will work the same. It will expose you this extension, and then you call whatever API you're interested in. So this can be simplified or written in a more nicer way. Essentially, we take this runtime. So remember, we are inside the constructor. So your logic, so this common joke, I don't write the code in one method. In reality, it runs everything in one method, but not even the method, it runs it inside the constructor. So that's normal human being won't do in reality in any production code base. So that's happening for you. It just copies the content of your script and throws it to that constructor and runs it for you. And again, it typecasts to the public API called extension aware, gets a container called extensions, and from that extension container tries to configure new instance for us, and by configuring it, it delays it to the right time of the lifecycle execution. With the Kotlin equivalent, you will get something like this. You can still replace that nice Java and then opening the Lambda block with this code, and it still work, because essentially that's what's happening behind the scene for you. And this is happening, this is simplified due to the help of the accessor being shown here. And yet another version, you can simply go configure, pass the, if you know the type, you can pass exactly the extension time. This is not advised approach. Better it's to fall back to the string name, because behind the scene, this is Java as a keyword, as an alias. So let's say they release a new version of the plugin and they want to swap the extension for you. This will happen without your knowledge. If you still use the Java, you will be okay. If you use extension, then you probably might get a deprecation error, because better not to know about the extension. From one point of view, it's a cool thing. From another, it's much harder to understand what extension is capable to do, and that's why it's all this configuration that you see in those build Gradle files seems hard to follow. You need to know the type, you need to export. This is unfortunate, but maybe not unfortunate, is what we do every day in our work. So in the end, just wanted to highlight that when we work with the build Gradle file within the module, we actually work with, for Kotlin, with an instance called Kotlin build script. And as you can see, we get the host reference injected by Gradle for us. And from that, we get a target, and the target will be actually the project instance. The Groovy follows almost the same idea. It still comes up with a program for us to be compiled. This is very simplified. This is not taken from the source code directly, but that's what's happening behind the scene. It again creates somewhere the project instance for us, creates something called binding, and make sure that our compiled file, our script, it compiles for us this class called build and then hash code and passes this building. After that, calling the run method over the script. So something simple as this. So there's only 2 lines. I'm skipping the part about the plugins. Just grab me the current project. This is what you can write in build Gradle file under the module and assign this receiver. We have no idea who we are to the some undefined type behind the scene. The Groovy will come up with something like this. It's very hard to read, hard to follow, but essentially this comes out of the fact that Groovy can address type, extend the types. It also interprets the code for you. It manipulates the bytecode and through reflection makes the calls, passes the references of the delegate. And then you can see that we pass this instance is again the project object. We make sure that we specify that it's a project class type. So again, let's come back. So this code here produces something like this. And the idea is all about the call site array. So it's for every line of code, it will generate an object and call this for you. With the second line, it's pretty straightforward. It just creates an assignment. And it just proves the fact that whatever you put inside your build Gradle files actually gets executed from within synthetic class. So the call site objects responsible for resolving, invoking the methods for us, and delegate also the context of the project into the script. So speaking about the Gradle API surface, this is the part I mentioned in the beginning. I find the most important to know about, especially if you're working with the Android ecosystem. So first thing starts with the project class. Through project, you can get an access to the extensions through extension container. And extensions, not only those, but most of those types is getting love to work with something called name domain object set. This is very. I will have a separate set of slides for this. So I wanted first to focus on the extension type. So this is a way for the plugin developer to give you an entry point into the configuration. This is pretty straightforward code that you find in any code base of Android. You actually working with an extension type at the runtime. In Kotlin script, it's an accessor that I mentioned and showed for you, but in reality, it simply calls extension aware, get extensions, get Android, and then within this block, we start to mutate its properties. So the extension container project implements the extension aware interface that has get extensions method, and not only the project, you will also find in the default task class ability to generate extensions for the tests or whatever task you want. So as an example, we can take a look and implement more variables logging in your tests. You don't want to run it in, let's say, every time you run it from local, but for CI it might be useful to enable some extension, some additional logic for your tests. And one way to do this is to define the extension type, add it to every test task, and then within every test task, access the extension. So the extension looks most of the time as an abstract class. You can put an inject statement and get an access to something. This is actually the good example of service dependency service locator. It gives us access to providers, and the Gradle property is the way for us to read this -p variables test name out of the runtime or fall back to the false value if it's not available. Then for every task within the project, we will create an extension, and then we can access this extension either by this or by calling directly the Gradle APIs, because this comes from the Kotlin DSL. calling this enable verbose method and then configuring the test logging exception format, whatever. It's not that this part is not that important only this. So as soon as we have at the runtime, at call, it could be from the command line or from the Android Studio. If you add this property, you will get a different exception format as you execute this code. So remember me speaking about name domain object set. It's very overloaded, very complex and to understand, but its idea is as simple as with an extensions, you type the word release, and behind the scene is just a string. And to make an association between word release and the type that you configure over, the Gradle came up with name domain object set. So the way how you can work or access this container is there is multiple ways. The one fancy is by calling getting, which delegates to the name that we put here. So if you put release 2, it will fail. Release is one of the default build types that we have in Gradle. You can access directly by name, and yet another third approach you can call named. And in all those three cases, we will get the same instance of the release build type for us to work with. So the most known application of the name domain object class in Android are the product flavors. You can put free, you could put paid, whatever word, and it will, behind the scene, be translated to just a string. The same goes with the source sets. The same goes even with the dependencies block. So this keyword implementation, it just translates it back to the keyword, to the string code implementation and says dependencies, configurations, get configuration implementation, and then pass this ID. So just as a summary of this whole talk, this is just one slide that sums it all up. Whenever you work with the build script at the root of your project, you will get the settings reference. When you work with a module, you will get the instance of the project. And the third type, the Gradle type, is less known, but it's something that you could put under init.d folder within your Gradle folder within the project, and it will execute the script for you. It's used by the enterprise. Netflix does this. They ship the custom version of the Gradle jar that comes with this init.d folder within which exists the build Gradle file, and they make sure that they apply and use the same plugins across all the code bases. So this would be the final slide, but we still have a time, and I wanted to quickly showcase you an example of how you can actually do the debugging around the Gradle scripts, which I found very useful. If you want to explore, this would be, yeah, let me see.
Thank you.
Yep.
A little bit more?
A little bit more, but I will highlight it here, better contrast. So first thing, you need to put, it still highlights it. I don't know why it highlights dd, but it's -d or Gradle debug true. And the tasks is a default task that you can run for any module. So as soon as you work with any Gradle project, you can call tasks and it will exist. So I make sure that I call it with d or Gradle debug true. Oops, let me do the trick. Yes, this is the part I was afraid of. I've also modified my Gradle wrapper bash script, because it is the way how we run the Gradle. We simply call the Java process and pass a path to the jar, and then within jar it looks for the class called Gradle wrapper main, and then it passes actually the command line. Here, GV is an alias from my command line, but exactly that's what I was doing. I just realized that this might be better. So it starts Gradle daemon for us, so it waits for us to connect to the code, And then you go to the Android Studio, you type attach to process, and it shows you the process you can attach to. Let's see. Let's attach to another one. I think I have multiple instances. So let me kill everything and try once again. Hopefully this one. Come on. Let's do this way as well. Now it executes because nothing stops it. Hopefully the third time will work. Ta-da! So we are now within the source code of the Gradle, Kotlin Gradle KTS library. And then you will find class code interpreter, which comes with very nice explanation. This is essentially what I was speaking about, the plugins block, build script block, and the partial evaluation. It's all described in this source code. Here is even the type C also. But that's not that much interesting now. The most interesting part comes here. You could drop here a breakpoint, and then you can see the compiled code or the classes where they're existing. Remember, I'm saying that it lives inside your Gradle home folder caches, and then you see that it creates us build Gradle file and program class file. Let's see if I will be successful to open this. And here those are the classes. So let me drag and drop it. So this is the code you saw on the presentation. This is the program. And it has an execute method that this class that we are currently debugging through the interpreter will call for us. This is the execute method. It will enter this code and will start collecting the specification for the plugins dependencies. And see, plugins block line number 2. It injects also this information, so it no longer needs to evaluate it once more during the runtime. Plus, it caches the stuff. And another trick, which I don't know why it's not showing the proper stack trace when you do the debugging, but you can still call thread current thread get stack trace. You get the nice stack trace here. You copy it at everything that is interesting for you and throw it to the analyze stack trace thread and dump. And from here you can see what's happening behind the scene. So remember me speaking about build operation. This is also a place where you can just drop the source code, find it through the source code searcher, and then throw the breakpoint. And you can see I've just disabled it, but essentially it just wraps every task into the run build operation class and runs over it, passing some additional build operation context. So you can take into the inners of what's happening behind the scene pretty easily with Android Studio in combination with -d or Gradle debug true statement. So let me release it. And all done. We should be able to see the list of the tasks. And you can see it was waiting as long. It will wait as much as you need it to wait for the all code to be executed. Another thing which is unfortunate, you cannot do something like this here, right? But it's not a great problem. Now you know that what stands behind the scene, right? So you know that it's called Java plugin extension. You can go and directly find the setter we are interested in. Set. And throw here the breakpoint. And let's give it a try. I wasn't trying it before, which probably won't work, but I'm quite sure it should work. If it won't, well, another work for me. So set target compatibility. Maybe I wasn't calling. Of course, I've disabled it. So let's try. So we are back to the host, and here we are, set target compatibility. So this actually calls this line of code for us, and we can debug it. So it's I find it's useful if you do the plugin development, not that much useful that you need that you cannot do this from the Android Studio or IntelliJ IDEA. Maybe there exists a plugin. Unfortunately, I didn't find another way but just to know where this code ends up to be, and then simply throwing the breakpoints there, like I did in this demo. And let's me release it. So the last goodness I would like quickly to touch. This is the way how Gradle knows how to run those scripts. So when it sees the file, it checks its extension. It picks up default script plugin factory. I don't know why they don't pass it here. Maybe because this comes from the Kotlin, from the KTS library itself. But it will end up in the default script plugin factory and will evaluate your Groovy code. For KTS, it will run Kotlin script plugin factory. And then there is a third type, which I mentioned briefly in the beginning. This is a new way how Gradle wants us to configure projects without touching the Kotlin or Groovy directly. They try to squeeze the API surface in something smaller, which is better integrates with the tooling. And theoretically, you shouldn't be messing with this. But I have no idea how it will play out with the debugging and the other tooling that can help you understand how this works. So this is another homework to do. And this Kotlin script plugin factory is the way I figure out how and where things getting executed. So you see there is an evaluate method, and this evaluate method will end up actually calling in the interpreter, which instantiates the program for us. And if you take a look what actually instantiate means, it grabs the declared constructors and creates a new instance for us and executes the execute method, which goes here. Never tried this. Let's see. No, it won't do the trick. Yeah. Okay, it's already. Let me release it. No, it didn't work out, which is not surprising because I just grabbed the already compiled class, and the debugger class path doesn't see this file, so it cannot properly connect to it. So with the demo wrapping up, you have idea now that whenever you touch this file here, which lives under the module path, I've declared it here, you work with the project instance. So if I will write val self, I can typecast it to project and it will work. If you go into the settings file, you can write instead of project settings. And see, it's also not, if I will put project here, it will actually help us recognize that this is not it's a settings Gradle file. And you can see the nice explanation of what type you're working is. And also nice deprecation, which promotes the new DSL in the Kotlin, which we'll see how they are going to solve it. I'm also keen to see. That's basically all. So this is the end of the presentation. Hopefully you learned something new today, and feel free to get in touch with me here. Just make a photo. You'll find information about me, and this presentation is online. That's all.